Hello. Shall we get started? Okay. So my name is Heitinder. I work for Pro-tek Consulting. I'm manager of technology. And today I'll be speaking about evolution of JavaScript. What pretty much I'm going to talk about is how JavaScript started as a language for the web to create sites which are interactive, dynamic, and we can change a lot of things on fly, and how it has evolved from a language just for the web to the most popular language for programming, and how it has extended from just a language for the web to server side, and then from server side it went to things that are not related to web at all. For example, drones and cars and such as. We know JavaScript as glue of the internet. So, am I audible? Okay. So, as we know, JavaScript is also known as the glue of the internet. So, the first thing that we're going to talk about in this presentation is the history of JavaScript, how it was developed, what was the purpose for which it was developed, and some of the technical things, the science behind the evolution of JavaScript, or let's just say the invention of JavaScript. And then we're going to see some examples of how JavaScript, it came a long way from just being a language for the web. So we're going to see some examples for that. But before that, we're going to see what are all the ingredients that we need in order to create a web page, or I like to call what are all the ingredients of the recipe of the web page. So the first thing that we need to know about is a web browser. So we all know what that is. Google Chrome, Firefox, Safari. Then there is an engine called JavaScript engine. The most popular one right now is V8 engine. It's the one that runs the JavaScript, that compiles the JavaScript. That's the link between programming language and machine. And then we're going to talk about actual JavaScript code, and then HTML, how HTML is rendered in the page and how it's changed when JavaScript is applied on an HTML page. Before that, we need to know what is JavaScript. So JavaScript was a language that was developed, the first JavaScript version was developed in 10 days by a person called EICH, and he was working at NETSCAPE back then. Now he's currently working for Mozilla, and not anymore. Where is he working at right now?
He got ousted because of the big scandal.
Oh yeah, we all remember that. Right? He got outed because of the big scandal, but he was working at NETSCAPE back then. So he was the one who started JavaScript, and the first version of JavaScript was created in 10 days. So before we talk about how the evolution took place, we need to know the anatomy of a web page. What does a web page constitute? What are all the things that are part of the web page? So HTML5 is the one where you build your web page, and CSS is used to style your web page, and JavaScript applies the functionality on the web page. So you can see there's 3 layers. One is the layer of visualization, which is HTML and CSS, and one layer is for functionality as well as for data exchange, and that's JavaScript. JavaScript is very useful. So we're going to see what are the most common uses of JavaScript that are available to us, and one of them is, it's event-driven programming. So we have keyboards, we have mouse. We can also interact with certain other events such as ready, onload, things of that nature. Then we can also access hardwares. You can access microphones. You can use various different APIs and plugins to access things such as monitors and speakers. Then you also need data. So that's the third thing right next to HTML5 and CSS3 is your JSON. And then we also have web servers and APIs. So that's what JavaScript uses in order for us to run a complete web page. And we're also going to see in this presentation that JavaScript is everywhere around us. For example, it's built into your browser. Every browser that we are using right now is running on an engine that has JavaScript on top of it. It's used on pretty much most of all the tablets right now. It's used in every single smartphone. Almost 2 billion computers are running on JavaScript, and plenty of other places. Now there is a graph that was, there was a research that was done in 2013 which shows the popularity of JavaScript according to the projects that are available on GitHub, as well as people that are using Stack Overflow their questions. Compared to any other programming language, JavaScript tops that. So that shows how popular JavaScript is getting today and how popular it still was 2 years back. So Brandon H., who developed JavaScript, he said that after 18 years, he said it's 18 now, so it's not his responsibility of JavaScript, so it can go, it can vote, it can join the Navy. But what he was trying to say is he wanted to give JavaScripts to developers so they can create something out of it, not just for the web, so they can create something to implement MVC architecture on the client side, things like AngularJS, things like Backbone, or use it on the backend server side using Node.js. We also have Marionette. We have isomorphic JavaScript is what we call it. That means JavaScript morphs according to where it needed to be used, be it a server side, be it a client side. So we're going to talk a little bit about history, why JavaScript started, what was the need for it, and then how did it came into a place where it is today. So initially we have the media, we had the print media, we had the video media, we had the gaming. So what they wanted to do is, because in 1995, I'm talking, they had internet and it was getting popular back then. So they wanted to share things, right? The print media wanted to have their presence everywhere in the world. I mean, you can't print and send it. I mean, you can print and send it to everywhere in the world, but will take, it's a long process, right? Same thing with the movies, same thing with the games. So they wanted to have a platform where they can share about all these things. So that's where the need for JavaScript, or need to make web pages dynamic, kind of arises. So that's where the real need for JavaScript was felt. But in 1995, the web was a lot different than what it is today. We didn't have things like Twitter. We didn't have things like Facebook. We didn't have things like Google back then. So the first few web pages, how did they look like? They looked like this. Very informative, right? They were not very interactive. They were not doing a lot more, you didn't have a lot more interaction with the web page. You couldn't really, like right now, you can send messages. You could not really do much with the web page rather than just reading off it and having information. Those were the initial browsers, Internet Explorer and NETSCAPE, and that's how it looked back in 1995. So at NETSCAPE, they said they aimed at a language that will be a glue for the web designers and programmers. And back then, they saw Java developers as Java as a component language, and it was used for higher priced programmers back then. So that's where the need for JavaScript arose. So that's Brandon H. And the first name for the first version of JavaScript that was created in 10 days, it was called MOCHA. Now we'll get to how JavaScript is becoming useful and how it's evolving to what it is today. So they said the earlier computers that were developed by IBM, they were very slow and they were kind of hard to use. I mean, you kind of have to be a programmer in order to use those computers. Back in the days, they were kind of really slow. So they wanted to create a language that should not be slow and that should not be hard to learn or hard to use. So the first very early phases of JavaScript that we saw was a mixture of HTML and JavaScript, and it's known as DHTML or dynamic HTML. So you can do things like form validation, or like a simple rollover where you roll over an image and it changes, or like pop-ups or tickers. Back in the day, that was the extent of JavaScript. In 2000, something changed. We came up with a concept called Web 2.0, where the sites became a little more interactive, and we have XHR, which is XML HTTP request object. What happened with that is you can do communication with the server now, and server gives you a response in a format known as XML. So that was the first time web became interactive, and the first few players that brought this into the picture were Outlook, Microsoft Outlook Web, Gmail by Google, and Google Maps in 2005. Later on, they started using XHR. But the real advantage was taken by somebody known as Jesse James Garrett, and he was the first person to introduce AJAX. AJAX, also known as AJAX, stands for Asynchronous JavaScript and XML, And it's a technique of sharing data with the server and then getting the data back to the client side and updating the page without reloading the rest of the page. So before this, every time they had to update something on the page dynamically, the page has to reload. Even if they were using XHR, the page was still reloading. But when AJAX came in the picture, they didn't have to reload the web page very often. If they need to make any update, they would just use AJAX. So now we have AJAX, we have XML. Where will it go next? Before that, we need to understand how all the things that place JavaScript, things like web browsers, things like emulators, things like compilers, how do they all work in the background? So the first thing is a web browser, right? So what goes inside a web browser? So web browser has a user interface that connects to the data, right? Then it has a browsing engine. I was talking earlier about V8. V8 is the current engine. It's very powerful. That's what a lot of the browsers are using right now. Then there's a rendering engine because we have network, that internet. So we need a language we need a compiler that can change that programming language into a machine level language. So we do need a rendering engine that connects to the JS engine as well as networking, and then they affect the UI, and that's where the display comes in, and the data also comes through the browser engine of the JavaScript. So we have a lexer where it generates the token, and that token is more used for like an authentication and authorization of the web page, and that's what the parser does. It checks, it validates the authentication, and then the translator it translates the JavaScript language into a machine level language, and the interpret, it creates a native code for any kind of device which you are using JavaScript on. It does that. It creates a native code out of the code that has been converted into a bytecode now. So then we are talking about compiler. How does a compiler work? A compiler has 4 compilers. Every time JavaScript changes itself, there's a compiler that compiles into the real code that's being used. So for example, if we need an access tokens, a compiler will compile them into authorization and authentication request format, and then it will change it into a byte format, and then the byte format will be changed into a native code that could be understood by the machine. So a browser engine works with 4 compilers. So you have compilers for every single step, and then the engine, which is inbuilt in the browser, helps the JavaScript to be applied onto the web page. Now, every time we write a JavaScript, writing JavaScript is one thing, but writing correct JavaScript is another thing. So that's why we have so many web standards right now, because we want JavaScript to be we want it to be fast so that the pages load faster, so that we can reduce the load time of the pages, highly interactive. And they also needs to be slim. By slim, I mean the amount of time it takes to write code. That's why we have so much frameworks and libraries for JavaScript, which has a lot of inbuilt API, a lot of inbuilt functionality, so that we don't have to write a lot of the code manually. And it has to be correct. That means it has to follow all the web standards that are by either W3C or ECMA. So we have to follow all the standards. So let's take a look real quick about what they are and what does it really mean. So by fast means that we need a code that can accomplish a lot more work in a very little time, and it should be able to tackle complex tasks. And by slim means that your code should download faster, and it can be compiled faster, and by correct means that it should do what it's expected to do. So again, Brandon H., the guy who developed JavaScript, he said, you can pick any 2 as long as the third one is correct. So pretty much he's saying is you need all 3 of them in order for your application to work. And here is the earlier 1998, the earlier versions of JavaScript engines. We had SpiderMonkey in there, we had JScript in there, but none of them were really fast, or they were slim, or they were correct. They were not supporting anything. After 1998, we have web standards, things like ECMA, things like Web Standard Project, W3C. So some level of correction was introduced into JavaScript by these standards. They still keep updating. Like right now we are on ECMA 6, so there's a lot more web standards that have been introduced, but every year they keep updating the new standards, and they're keeping JavaScript in check by implementing those standards. Then I just wanted to give a quick example of what do I mean by slim. So this is like a code that is in native JavaScript that's looking for an ID that starts with create non-ID. But this is what you can do in jQuery. It does the same exact thing, but you can see how less of a code that you have to write in order to achieve what we used to try to achieve using JavaScript. So that's what I meant by slim. And this happened because to understand jQuery, they introduced a lot more JavaScript engines, and V8 was introduced first in 2006. Now we're going to talk about how to make JavaScript fast. So think of this as an engine. It takes in the JavaScript code, something magic happens inside, and gives you a fast native code. So think of this unicorn as a JavaScript V8 engine that takes in the JavaScript code, something magic happens inside it, and gives you a native JavaScript code. And that, again, the fast part of the presentation today, it happened because of the availability of V8 engine that supports a lot of the techniques that we are using today. So a Stack Overflow member said any application that can be written in JavaScript will eventually be written in JavaScript. So in 2009, he foresaw the future, and he said, pretty much what he said in simple terms is JavaScript is going to be everywhere. So let's see what JavaScript is used nowadays, or at least what developers are trying to use it as. So one of the common example is JavaScript is used to develop games. So a few of my favorite games that were developed using JavaScript are Angry Birds, Plant vs. Zombies, and Farmville. There is a language for that. It's called WebGL, which is again based on JavaScript, known as web gaming language. Another good example would be visualization. So we have so many different visualization libraries available for us for JavaScript, things like D3.js, C3.js, high charts, rickshaw charts, and even your Uber, when you set something by location, all their visualization, that is also done in JavaScript. Then JavaScript is used for WebRTC, which is also known as real-time communication. Your Google Hangout audio and video plugins you can access, and you can talk in real time. And another thing is your Facebook chat. Any kind of chatting or video or audio conferencing can be achieved using this WebRTC. So that's just another step that JavaScript is taking towards communication. Now JavaScript has also came into hardware, but before that we need to understand what made it possible for JavaScript to access hardware or to access machines. What made it possible? Because it's a programming language, so how does it's doing so much? Because they are using JavaScript as a compiler. You don't need an actual compiler. You can use JavaScript as a compiler. Things that were done in languages like C or Java, now JavaScript as an emulator you can use, and you can run it on PC, and you can do a lot of the things that JavaScript used to do. A lot of the different emulators used to do such things like Spectrum or C64. JavaScript is doing a lot of the things because of HTML5, right? The HTML5, it came in picture, and it let JavaScript use as an emulator. And then you can also use it as a compiler. So things like Pascal or Lua, what they were doing in the past, now JavaScript has those abilities to do that. Plus JavaScript, you can also use it as a money. So we all know the concept of Bitcoin, how Bitcoins work. So Bitcoin is not a currency, but JavaScript lets you use that as a currency over the web if you want to buy something. And so that currency is again written in JavaScript. Now JavaScript as a data. So in 2006, Douglas Crawford came up with the format. Before that, we talked about XHR, and the format that they were using in order to exchange data from server to client side was an XML format, right? But with JSON, what happened is they minified that code, and it was readable not just to the machine but also to the developer. So this is an example of an XML code. So as it says, the object is person, and then the properties are name and discovers and employer. And here is an example of a JSON format. It's much easier to read. It's very clear to the developer, as well as it's very clear to the machine. So it's known as lightweight way of exchanging the data. And with that JSON, we have things like NoSQL databases, things like MongoDB that handles JSON pretty good. We have CouchDB that again handles that pretty good. So what happened is a lot of the devices out of the box, they use JSON data, the devices that you use every day. One of the common devices that uses JSON is your thermostat. That's that's provided by Apple, that you can sync with your phone and you can set the temperature of your house. Another good example would be Mercedes, right? All your maps that are in Mercedes are the settings that you make by default. They get stored in a format, in the JSON format, so that's easily read by the machine. Now we're going to talk about JavaScript as a server, because JavaScript has its own data, JSON format. It has its own emulation, because you can use it as an emulator. JavaScript, you can use it as a compiler. So with all these things possible, now you can extend the functionality of JavaScript from client side to the server. So JavaScript can be used on the server using Node.js. So what Node.js does is it takes the engine and it wraps the Node.js around that engine. So you just pretty much, it's the basic engine that's for the JavaScript, and Node.js was developed around that engine. What happened is, now with that, you don't need a browser. You can cut off the browser from there, so you don't need a browser to run the JavaScript anymore. JavaScript has its own compiler, so you can run it on the server side, and you can do automations on the desktop using JavaScript. So a lot of the tools that use Node.js and does automation without using browser is things like grunt.js to minify your code, to concatenate your code, to run unit tests. You use a task runner, things like grunt.js, gulp.js. For package management, you can use things like Bower. And then also there's tools that you can use that run, they don't need your browser, they just use Node.js, like your Photoshop generator. Now the next step is, we covered the web, right? We covered the front end, we created a server, Node.js server, we covered the back end. Now how it's moving towards hardware. So JavaScript can be used on the board. Raspberry Pi is one of the good example is they have their own JS and it works on the JavaScript. So it takes a lot of the JavaScript API, so you can use your cell phone or your tablet, and you can run JavaScript application that will this board can run that, and it can make changes on whatsoever it's needed for. So one of an example is the aquarium, and the framework that they're using is called aquarium.js, and what they do is they use your cell phone or your tablet, and then you can use aquarium.js framework, and you can change the ambience or the surroundings that are inside the aquarium. So after that, a lot of different microcontrollers came in. Arduino is one that's used heavily in robots. So if you use robots or if you use any kind of drone, Arduino is definitely used. So what happened with using Node.js and Wi-Fi extension, you can now use a Node.js server and you can extend it over a Wi-Fi to access those robots. So that's the next step. So it's not just limited to web anymore. It's going out there for. You can also use it in the drones. There is another framework for that. It's known as AR drone that let you control drones that are using Node.js as their server for Wi-Fi extension, which uses JavaScript in the background, which uses a V8 engine. So that's where it's extending to the robots as well. So let's see what all things JavaScript are doing right now. So we all know the basic anatomy of the web page that we saw earlier, HTML5, CSS3, JavaScript. That's your regular web page. Then languages like C and Java, what they were doing on the server can be done. The same thing can be done using Node.js for server-side rendering. Then it can also use itself as a compiler like Lua or Pascal. So that's something that can be done by JavaScript. Then you can use JSON data to run it on devices such as Nest or as we saw earlier, cars. Then the V8 engine, you can control that V8 engine by a web browser, which can again be controlled by your devices, be it a handheld device or it's a PC. And that V8 engine can use Node.js, which can again control a computer or a board, a microcontroller, which can control things like drones. Maybe in future it could also be control, self-driving cars. So that's what the evolution of JavaScript is today, and that's what a lot of the people are working on. So that's what my presentation is all about, how JavaScript has evolved from a language that was pretty much created to use on the web, and now it has moved from the web towards computer boards, towards drones. So that is all from my side. And I just also wanted to talk about this initiative that we are giving back to the community. We have a magazine called UI Street, and it's primarily for web development on the front end, and we write a lot of new topics on it. We write the best practices that are in the market, a lot of interview questions in there. And if you want to grab a copy, I'll have a few copies with me, but you can also go on usstreet.com and you can subscribe it. We do a new edition every month. So thank you, everybody. That's my time.